Hi everyone, I'm Sean and today I'll be sharing about my final year project, which is to design a multifunctional clothes folding machine using Arduino. I'll be covering 4 main points: an introduction to my project, my progress, the challenges I faced, and my next steps. The problem I'm addressing is laundry folding, a task that many find time consuming and tedious. Folding laundry can take up a significant amount of time, and a quick online search reveals that this is a widely shared frustration worldwide. This issue is also relevant here in Singapore, where busy lifestyles make it difficult to find time for household chores like laundry folding. Thus, my project seeks to automate laundry folding to save time and reduce mental load, enhancing productivity and work-life balance. The base structure of my machine consists of 4 folding arms. It will start by folding the bottom arm, followed by the 2 side arms, and lastly the top arm. I also plan to integrate a steam ironing feature into my machine. This requires 2 sliding mechanisms, one for height adjustment and another for horizontal movement to evenly steam clothes. After ironing, the iron will reposition itself to avoid interfering with the folding process. Here's a quick animation showing how it works. I'll now share my progress in 3 areas: component research, programming and testing, and prototyping. In research, I discovered the sliding mechanism uses a NEMA 11 stepper motor, which requires an A4988 driver and a 100 microfarad capacitor to stabilize the power. In addition, I began learning AutoCAD as I plan to use 3D printing for certain parts of the machine as well. Next, I also took time to familiarize myself with Arduino programming through the use of a virtual simulation platform. Using this platform, I developed the foundational code for my 4 servo motors to rotate 90 degrees in sequence and return to their original position when I press a button. Next, I recreated the circuit in simulation with actual components for prototyping and assembled them. Here's a short demo of the base structure of the clothes folding machine. Because of the limitations of the small servo motor, I couldn't fully recreate the base structure. However, this prototype confirms that with a stronger motor, the machine should function as intended. Through this process, I also realized the importance of the folding arm size and positioning, specifically how the size and position of each arm impacts the sequence in which they should operate. A challenge I faced while working on the prototype was button bounce. When I first connected the button and servo motors as I had in the simulated circuit, I noticed that the servo motors would start the sequence immediately and ignore the button inputs. After some research, I learned that this was due to button bounce, a phenomenon where the button signal fluctuates rapidly between the high and low states. To address this, I found 2 possible solutions: adding a 10k ohm resistor to the ground side of the button to stabilize the signal, or implementing a debounce function with a 50 millisecond delay. I chose the second method and it worked successfully. For my future work, I will need to test the steam iron, integrate the sliding mechanism, calibrate motors, and potentially add a smart tray collection system. Thank you.